When we are factoring, it's really important to remember that factoring is not just quadratic factoring, but factoring is factoring of numbers, factoring of terms. Okay, so when we have these terms here, we always look for the greatest common factor first. So before I do any kind of factoring, I'm going to look at all these terms, and I'm going to factor the greatest common factor. So there's common 3, there's common x. Okay, so what's left over is going to be x squared minus 5x plus 4. Now we could see if this factors further. This is a quadratic, but in this case here we're finished because there's no numbers that multiply to 4 and add to 5. So that's factored, and it's important that we factor the greatest common factor because those factor pieces are going to be really important when we do math in further in grade 10 and also in grade 11, 12 and calculus. Factors are really important. So here the greatest common factor of the numbers is going to be 7. The biggest divisor of x is going to be x. For y's, I've got y squared will go into all of these. Okay, and those are the only terms that I have. So I end up with 2xy left over here. Divide this by 7xy squared. I end up with 3. No x's, y4. So when the x's cancel, I have no x's. I don't have just x with no number on it. It's just no x's. Plus 7 divided by 7 is 1. X squared divided by x is x. Y squared divided by y squared is 1. Now we could put the 1's in there, but times by 1 doesn't show up. Here we get 35 divided by 7. x4 divided by x is x cubed. y5 divided by y cubed, y squared is y cubed. So there's my factored terms. Here, remember that this whole piece is a factor. It's grouped together as a multiplier. It's connected by time, so it's a factor. And it is common to both of these. So we're going to treat that as our greatest common factor. X plus 7y, and then what's left over is going to be my x minus 3. Okay, so if I take away the x, or if I divide out the x plus 7, I'm left with x. If I divide out the x plus 7y here, I'm left with just the 3. It's important to be able to draw the algebra tile representations for these, and it doesn't ask to represent it in a rectangle, but since we are going to factor, it's good to be able to show the rectangle for these. So I'm going to draw my x squared minus 4x's like this, and I'm going to put 1 here because I want to end up with a rectangle with 3 1's. Okay, and again, if the shading, it doesn't really matter to me as long as you're consistent. So if my positives are white, my negatives are black, or vice versa. Since we have a rectangle here, I can write this as length and width. So we can factor this into x minus 3, x minus 1. Okay, this one's given in factored form, so I know that the outside should be 2x minus 1 and x plus 3. And that's going to give us x squared, 2x squareds. It's going to give us a minus x, and then plus, looks like it's going to give us plus 6x's. And minus 3 1's. Okay, so when we can show the expansion for this is going to be 2x squared minus, or it's going to be plus 6 minus 1, so plus 5x, and minus 3 1.